Hello, this is AseelElzamel, and in this video I'll be showing you my fraud detection project. It's designed to identify fraudulent credit card transactions by combining Java and Python. Java handles the main control while Python does the data analysis and machine learning. We'll first run the program so you can see it in action, and then I'll walk you through what's happening behind the scenes and show you the results visually. This is how it looks. Here I have the project ready to run. The Java program acts like the conductor of the orchestra. It doesn't play the music itself, but it directs the Python, you know what I mean? Which does the heavy lifting with the data and models. I just pressed run, but it's going to take a minute to actually start running. And as soon as I started it, Java called a Python script, and the first step in Python is to load the dataset. This is a CSV file of credit card transaction, which each labeled as either fraud or legitimate. Before we train the models, we clean the data and we check for missing or incorrect values, and then rebalance it. This is important because fraud is rare in real life, and this data set, only about 1 in every 500 transactions is fraudulent. So without balancing, the model might just predict no fraud all the time. So once the data is ready, Python trains 4 machine learning models: logistic regression, decision tree, random forest, and XGBoost. Each one tries to learn patterns that separate fraud from normal activity. We then evaluate them using 3 metrics: accuracy, F1 score, ROC, AUC. The accuracy is the percentage of correct predictions overall. F1 score is a balance between catching fraud and avoiding false alarm. ROC, AUC is a measure of how well the model distinguishes fraud from non-fraud. For example, if ROC, AUC is 1.0, it means the model is perfect at ranking fraud above legitimate transactions. A score of 0.5 means it's no better than guessing. This is taking a minute, but it'll pop up any second now. And there you go, here's the output. And the best model is Random Forest with ROC AUC score of 0.9995. That's nearly perfect, which means it's extremely reliable, separating fraud from normal transactions. Now let me explain the results more visually for you. Over here, I have the system architecture. This diagram shows what you just saw. The process starts in Java, which launches Python, and then Python loads and processes the dataset, trains the models, and then sends the best models details back to Java for display. Let me zoom in for the second figure. Here's the data pipeline in detail. We start with the raw CSV data, and then we clean it, and then rebalance it so fraud cases aren't ignored, and then feed it into the model training process. That balancing step is critical. In banking, missing even a small percentage of fraud can mean a big financial losses. Now for the model comparison bar chart. This chart shows how all 4 models performed. Random Forest, this one over here, outperforms the other in every metric. For example, its F1 score is the highest, meaning it's both catching more fraud and keeping false alarms low. This is the confusion matrix for Random Forest. This large number over here and this large number over there mean the model correctly classified more transactions, whether fraudulent or legitimate. The very small number in the other 2 boxes mean it rarely makes any mistakes. In real-world terms, this means the system could be used to help banks automatically flag suspicious transactions for review, while letting genuine transactions pass without delay. What's so powerful is the combination of Java stability with Python's machine learning libraries. It gives us a flexible yet reliable fraud detection system. By running multiple models and picking the best one, we've created a solution that's accurate, fast, and adaptable to new data. Thank you so much for watching, and I'd be very happy to answer your questions.